Let us now deal with an asymmetric key crypto system called as ElGamal Cryptosystem. Since it is an asymmetric key crypto system, it uses different keys for encryption as well as decryption. In this case, it uses a public key for encryption, a public key of the receiver, and a private key for decryption. The public key in this case is a combination of three different numbers. The first number being a prime, which you can choose to be greater than 26 in our case for convenience, because there are 26 letters in the English alphabet. But in real life, the size of the prime chosen is around 300 digits or more. Okay, so let us say in our case, I choose 31. You can choose 29 also. R is actually a primitive root of P. We know that every prime P has a primitive root, and there are phi of P primitive roots for every prime P. In this case, you will have phi of 31 phi of 31, which means there will be phi of 30 primitive roots. You can calculate this. One among those primitive roots is actually 2. 2 is the smallest of all primitive roots. So you can choose for convenience 2 as the primitive root in this case. Now the A chosen, though it is made public, nobody knows what this A has got to do with this R. Since it is very easy here in this case because the numbers are small, we know that 8 is nothing but R raised to 3. That 3 is actually the private key. So the private key is actually the power to which this 2 is raised, this R is raised to get your A. Okay, so you have to remember this. The public key contains three different numbers, PRA, the first number being a prime greater than 26. R is a primitive root of P, and the A chosen is such that it is a power of R modulo P. Okay, now let's go to the second step, which is the encryption process. The encryption process involves converting a plain text into a combination of two different ciphertexts, where the first ciphertext is actually the primitive root raised to some power, let us call it as J. The second ciphertext is the plain text times A, which is the third number of our public key, raised to the same power J, where J is any number that you can choose between 1 and P minus 1, which in our case will be 31 minus 1, 30. So let's say our J, let's choose our J to be again 2 for simplicity. And let's calculate our C1 in this case. So C1 is going to be, C1 here is going to be R raised to J. R in our case is 2. So it's 2 raised to 2, which is 4 modulo 31. Let's remember this. So C1 is always going to be constant forever for every plain text because it is not depending, the formula doesn't depend on the plain text. C2 is something that depends on the plain text. So C2 is P times A raised to J. Let us calculate that and keep. What is our A? A was 8 raised to J. J in our case is 2. So it is P multiplied by 64. If you divide 64 by 31, you get 64 divided by 31, you get 62, which is 2, right? Okay, so it's 2 modulo 31. 64 is congruent to 2 modulo 31. So we have a formula for finding out our C2. C2 is nothing but P times 64, which is P times 2 modulo 31. Now with the help of this C1 and C2, let's encrypt our message. Let's say I want to encrypt the message H. I mean, you can have a long string of letters. For simplicity again, I am just looking at one letter. The letter H has a numeric equivalent 7, which is our plain text numeric equivalent. C1 is already calculated to be 4 modulo 31. Let us calculate C2, which is depending on the plain text over here. Since the formula is P times 2, I will say it is 7 times 2 modulo 31. Now 7 times 2 is nothing but 14 modulo 31. So I have got my C2, which means I have encrypted the message H, which had a numeric equivalent 7, into a combination of two ciphertexts, one being 4 and the other being 14. Remember, C1 was 4 in our case and C2 is 14 in our case, and everything is happening modulo 31. This is how you encrypt a message using ElGamal Cryptosystem. Now let us go to the third step and also look at the decryption process. I will tell you the decryption process has a formula which something looks like this. It is plain text. The plain text is extracted from C2 and C1, of course, the ciphertexts, raised to some number. Let's look what that number is. Okay. So let's again recall our C2 was P times A raised to J. This is from the equation that we had here, equation number 3. C2 is P times A raised to J. C2 is P times A raised to J. From here, I want to extract the plain text. So I can multiply both sides by the inverse of A raised to J. I can multiply both sides by the inverse of A raised to J. So, sorry, A raised to J inverse. This gets cancelled and all I have left with me is P congruent to C2 times A raised to J. So I write here A raised to J, the whole inverse, provided the inverse of A raised to J exists. Okay, now I know that my equation number 1, which is A congruent to R raised to K modulo P, and I wanted to find out what is A raised to J. So I can raise both sides of this equation number 1 to J power. I will get A raised to J congruent to R raised to K, the whole raised to J. Now I can interchange the positions of J and K to get J inside. Why do I need this? Because I know what my R raised to J is. If you look at equation number 2, R raised to J is nothing but your C1 modulo P. So I can replace my R raised to J as C1. And because there is a K over here, the K stays over here. And I have a formula for my plain text now. Using equation number 4 and 5, I can write my plain text P as C2 times, this is the C2 times, instead of A raised to J, I now write C1 raised to K. C1 raised to K. So, as you can all see that to obtain the plain text P, you need the ciphertexts, both the ciphertexts and also the private key K, which is known only to the receiver. Okay. Now what is your C2? Let's now decrypt our message. Our message had C2, the ciphertext, as 14 and C1 as 4 raised to K. What is my K? If you remember, my K was 3. So I write there 4 raised to 3. Now let us first calculate what this 4 raised to 3 inverse is. What is 4 raised to 3 inverse? 4 raised to 3 inverse means 64, the whole inverse. But now let us make this 64 smaller. If you remember, the modulo that we are talking about here is 31. And 64 is way beyond 31. Let us write down the residue of 64 modulo 31, which is nothing but 2. So 64 inverse is actually same as 2 inverse. I need to find out a number which when multiplied to 2 gives me 1 modulo 31. This is called as the inverse of 2 modulo 31. What do you think that number would be? So you can do a trial and error method, or you can use Euclidean algorithm to find out that the inverse of 2. But I think in this case it is very easy. If you see that if you multiply 2 with 16, you get 32, and 32 is actually congruent to 1 modulo 31. So I have got my inverse of 2 as 16 modulo 31. Okay, so now I can substitute over here. I get 14 multiplied by 16 modulo 31. This is my plain text. But what is 14 multiplied by 16? 14 multiplied by 16 is 224 modulo 31. And 224, if you try to divide, I want to find out 224 is congruent to which number modulo 31, which means I want to find out the remainder obtained when you divide 224 by 31. If you check If you multiply 31 with 7, what do you get? 31 multiplied by 7 is 7, 7 3 is 21, you get 217 over here, and the remainder is 7. Okay, so this is the numeric equivalent of our plain text, which you know corresponds to the letter H, which is our plain text. And this is how the receiver gets the plain text through his private key. Remember, we are using an asymmetric key crypto system where the public key is a combination of 3 numbers, a prime number, a primitive root of that prime number, and some power of that primitive root. The power is only known to the receiver, which is the private key. For encryption process, you have to remember these steps. The plain text is converted into a combination, an ordered pair of ciphertexts where the first tuple is obtained by this formula. It is nothing but the primitive root raised to some random number, to which r is raised, and C2 is again the plain text times a raised to the same random number. And again, for decryption, you have to remember this. Even if you do not remember this, it is fine, but remember this formula. For obtaining the plain text, the formula is P is equal to C2 times C1 raised to the private key, the whole inverse of that. And that's it. Thank you so much for listening. All the best.